Good morning, children. Today we are going to discuss some in-text questions from page number 90 from the chapter The Periodic Classification of Elements. Our chapter is over, so we have only page number 90 in-text questions and the exercises from the chapter end. So today we are going to discuss only 6 questions from page number 90. Question number 1 is, how could the modern periodic table remove various anomalies of Mendeleev's periodic table? So we know that the modern periodic table by Henry Moseley is based on atomic number, while Mendeleev's periodic table was based on atomic mass. So therefore the anomalies of Mendeleev's periodic table were removed in the modern periodic table. Number 1, the isotopes of an element have same number of protons. We know that isotopes are atoms of same element having same atomic number but different mass numbers. As all the isotopes of an element is having one atomic number, they can be allotted in the same position in modern periodic table. And second one was cobalt and nickel in Mendeleev's periodic table. 2 of them are placed together in one slot, but according to when they are arranged according to the atomic number, cobalt and nickel are placed in different positions in the modern periodic table. And the third advantage of modern periodic table is hydrogen has been allotted a special position in the modern periodic table. It is placed at the top of alkali metals in the first group, but it has a special position in the periodic table. This is the second question. Name 2 elements you would expect to show chemical reactions similar to magnesium. What is the basis for your choice? We know that in a group, all the elements of the same group show similar chemical properties due to the same number of valence electrons, isn't it? So atomic number of magnesium is 12. Therefore, magnesium is having an electronic configuration 282. The number of outer electrons in magnesium atom is 2. Therefore, we can select any 2 elements from the second group. Okay, so here in the answer, beryllium and calcium are selected because beryllium is having an electronic configuration 2, 2 as the atomic number is 4, and calcium is having an electronic configuration 2, 8, 8, 2 as its atomic number is 20. And also beryllium oxide and magnesium oxide, they are metal oxides. Similar to magnesium oxide, they all are basic oxides. Hope it is clear to you. We are moving to the third question. Question number 3. 3 sub-questions are there. 3 elements that have a single electron in their outermost shell. So we know that if one single electron is there in the outermost shell means they belong to the first group. So you can write any member from the first group. So in the answer, lithium, sodium, potassium are given. Their electronic configuration also given in the answer, you can see. Second part is 2 elements that have 2 electrons in their outermost shell. So 2 electrons means they belong to the second group. So you can write any member from the second group. Here beryllium and calcium are given. You can write beryllium, magnesium, calcium, strontium, etc. Okay. Now 3 elements with filled outermost shells. So filled outermost shells means they will be noble gases. So you can write any member from the 18th group. They are noble gases. Here helium, neon and argon are given. Electronic configuration and atomic numbers are also given in the answer. Let's move to question number 4. Question number 4 is also having 2 parts. First part, lithium, sodium, potassium are all metals that react with water to liberate hydrogen gas. Is there any similarity in the atoms of these elements? So we know that lithium, sodium and potassium belong to first group. They are called alkali metals, isn't it? As the number of outer electrons are 1 in all of them, they show similar chemical properties. Okay, all of them react with water to form alkalis. We know that. Okay, what's the second question? Helium is an unreactive gas and neon is a gas of extremely low reactivity. What, if anything, do their atoms have in common? We know that helium and neon are noble gases. What is their speciality? They have fully filled last shell. Helium is having only one shell which is filled with 2 electrons, and neon is having 2 shells and both of them are filled. Its electronic configuration is 2,8. So they do not want to gain, lose or share electrons. They are unreactive. We'll move to question number 5. Question number 5 is, in the modern periodic table, which are the metals among the first 10 elements? So we have to write the first 10 elements: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. And we know that when you analyze the structure of the periodic table, lithium, beryllium and boron are coming in the left side of the periodic table. And also they have, lithium is having 1 electron in the last shell, beryllium 2 electrons and boron 3 electrons. All other elements given here are having 4 to 8 electrons in the outermost shell. So we know that if the electrons in the outermost shell is 1, 2 or 3, they will lose electrons and they are metals. So here lithium, beryllium and boron are the only metals given. We'll move to question number 6, which is the last question. Question number 6 is, by considering their position in the periodic table, which one of the following elements would you expect to have maximum metallic characteristics? So we know in the structure of periodic table, first group, second group and all the transition elements plus the orange colored elements are metals, and the green colored zigzag line is semi-metals, and all of them after the semi-metals are non-metals. So the number of non-metals are very less in the periodic table. Okay. Now here the question is, which is having the maximum metallic character? Okay. Now we know that as we move from left to right in the periodic table, the metallic character decreases. Okay. Among this, beryllium is coming first, isn't it? It belongs to the second group elements. So beryllium is having more metallic properties compared to any other metals or semi-metals given here. Arsenic is a semi-metal. Hope you understood it clearly. So in the next class, we will meet with chapter end exercises. Till then, take care and bye-bye.